to one side of the circle here. So D, we're going to take the 8 inches minus that radius, so minus 3 inches. So the L left over is going to be 5 inches. Okay. So practical application of this subtraction. Okay. Questions so far? All right. Good. So I think we're going to peek then at the next section, starting on page 29. Section 1-3 is the multiplication of whole numbers. Okay? So the multiplication of whole numbers here, we're going to, when we have a number of digits to multiply together, it's going to be lining up those columns again. So we'll do a couple examples before we get into, like what is expected. Now, in the beginning part here on pages 30 and 31, they look at those standard multiplication tables. You may remember from, I remember in 6th grade, Mr. Trottier's class, that was one thing that he had us do. He was our math teacher, and we would have to practice our facts, right? And then at some point during the semester, you would have to go and he would time you, and I forget what the amount of time was, but let's say in a minute, we would have to get through a certain number of them on a sheet. Do you guys remember doing that and having to like boom, boom, boom through those? And I remember we had to do it in front of the class. Every person would have to go in front of the class and do it. I hope they don't, that was pressure and anxiety, but we got to know our multiplication facts, or addition and subtraction and division for that matter. And so I look at this page and I remember, that experience. So I am not going to have you do that here in our industrial maintenance trades math class, but it's here. If you want to practice a little bit and you want to time yourself, it's kind of fun to see how you do. So it gives you on page 31 here, if you multiply these, the average time is about 100 seconds to get through all of these, okay? Evidently, there's a record of 37 seconds to get all the way through. So, and obviously, this would not be writing them out, probably saying them, in order. So if you wanted to kind of do that and see how well you compare to the numbers here, that'd be kind of fun to do. But I'm not going to do that here in class. So let's peek at. We're going to go ahead and we're going to go to page 36. Actually, yeah, page 36. And at the bottom, there's exercises here for us, 1-3. Now the first ones here are kind of those standard multiplications that we need to know, the 1 through 10s. So 7 times 6 we know is 42, 7 times 8 is 56, and so on. The ones that I think we're probably going to want to review the process for, especially in longhand, are the when we get into 2 and 3 and 4 digit multiplications. So we're going to peek down at number 25. And we're going to do number 25. I'll kind of show the process here. This is 47 times 6. And this kind of helps us to set up how we're going to want to make sure that we're aligning things as we write it out. So if we look at 47 times 6, okay? I start on the right-hand side here, and I'm going to multiply up. 6 times 7 is 42. I put the 2 down, right? And then I'm going to put the 4 on top. I'm going to take 6 times 4 is 24 plus the amount that I put on top. So plus 4. So that's going to be 28. So my number is 282. Multiplying 6 times 47. Now, knowing how I'm doing today, I think it's a good idea if I take 47 times 6 on my calculator, and sure enough, I did okay. It was 282. Okay? But it's always good to do that anyway. Even if you're doing it longhand or doing it in your head, it's not a bad idea to check. Okay? Going to the next type of problem here, let's look at number 27. Number 27 is 48 times 15. Okay? This adds an extra digit in that bottom number. So number 27, 48 times 15. Okay, so here, starting with the right-hand side, we're going to multiply up. 5 times 8 is 40. Put my 0 down, my 4 on top. 5 times 4 is 20 plus what I added up there, which was a 4, so that's going to be 24. Okay, now when I move to the next digit, Remember, I have to put a 0 in that ones spot, right? And then I'm going to start. Ones are always easy. It's kind of nice when you've got ones, right? So 1 times 8 is 8, so I put 8 directly below. And then 1 times 4 is 4, okay? I've exhausted my numbers here, so now I'm going to add these numbers going down. 0 plus 0 is 0. 4 plus 8 is 12, so I put the 2 down, carry the 1. 2, 3, and 7. So 720. Oh, no, it's not. Is that right?
That's correct.
It is 20. Okay, good. 48 times 15. Yep, 720. Excellent. Okay, so I did okay. Any questions on that process? Get to have more fun on bigger numbers up here. Why don't you go ahead and do 305 times 123? So at the top of page 37, number 1 here, 305 times 123. So we've got an extra digit in the bottom there again. So I'll do it here. 3 times 5 is 15, carry the 1. 3 times 0 is 0. I put the 1 down, we add 1 to it. And then 3 times 3 is 9. When I go to the 2, I put the 0 below. 2 times 5 is 10, so another 0, carry the 1. 2 times 0 is 0, plus 1 is 1, below the 9. And then 2 times 3 is 6. Now I'm in the 100 spot. I'm going to do 2 zeros before I get started, right? And then 1 times 5 is 5. 1 times 0 is 0. 1 times 3 is 3. Now here, this is when it becomes essential to make sure that your columns are lined up. Okay, if you start kind of going off, then all of a sudden you gotta, it gets harder to make sure that you're in alignment. So 5, 1, it's like 5 again, carry the 1, 7, and 3. So 37,515. Thank you. And it's confirmed. Okay. All right, so we'll be working together in class here as I do problems. I've been doing okay lately.
That's like my math status the same.
Yeah. Sometimes when I was a student, it looked like, oh, the teacher, it's easy to do this. But there's one challenge when you're teaching is to talk and to do at the same time. Quite honestly, it's not as easy as it maybe looks. So that I think is where I get a little balled up sometimes. All right, so good on process here. You guys feel comfortable? All right. And again, checking with your calculator is always a good idea. So let's do a couple practical applications down on page 37 here. Let's see. It looks like on number 6, it says a machinist needs 25 lengths of steel that are 9 inches long. Okay. What is the total length of steel that he needs? No allowance is required for cutting. So if I need 25 lengths, 9 inches each, I can take 9 times 25, right? So this is number 6. So I'm going to take 25 times 9. So 45. 5 goes down, 4 goes up. So 18 plus 4 is 22. So 225, it looks like inches, right? Is what he needs. Okay. Let's do another one. This one's pretty good. Now this is an automotive trade, which may not be completely applicable, the application of, but you may run into problems like this. It says 5 bolts are needed to mount a tire. How many bolts are needed to mount 4 tires on 60 cars? Okay. So 5 bolts per tire. So I don't know, I did this kind of step by step. So this is number 9. So I've got 5 bolts, it said, right, per tire, and I know that there's 4 tires on a car. So 5 times 4 is going to be 20, obviously, bolts, and this is per car, right? Okay. Now, I need to do 60 cars. So now I'm going to take 20 times 60, right? So I'm going to do 60. I like putting my larger number on the top when I do these multiplications. Times 20. It really wouldn't have made a difference in this case. but I'm going to do, oh, okay, 0 is this first one here. So I've got 0, 0 for the 0 and the 6. And then I'm going to put a 0 down here. And 2 times 0 is 0. And 2 times 6 is 12. Okay? So if I add this together, 0, 0, 2, 1. So I need 1,200 volts for a total of 60 cars, right?
We found like that, especially when you're working with 60 and 20 net, you can actually drop the 2 zeros and just do 2 times 6.
Yes.
Yeah.
Yes, I did it longhand here, but you may know that shortcut. When I'm working with zeros, it kind of makes things easy, right? So I can do 2 times 6, like you said, and I've got 2 zeros here, then I just add them to the end of the number. So 1, 2 for the 12 for the 2 times 6, and then the 2 zeros here, you can just add them in. You're right. If you know that shortcut, you can use that. All right, awesome. Let's do another one. This is kind of good. This will be applicable. Most often in industrial trades like you guys are in, you want to know what your production is going to be for any given time, or how long it's going to take me to complete an order for a customer. So here it says the hold type fastener plant produces 730,000 cotter pins per shift. Okay? If it operates 2 shifts per day, 5 days a week, how many cotter pins will they produce in 6 weeks? Go ahead. I'm going to let you kind of get this one started on your own. You know how to do this. This is very practical.
Oh, that's easy.
It is. It is.
I can do that in my head.
Oh, good. I'm not that good. We won't even attempt that one in Kelly's head.
No, it's really simple.
Is it?
You just use a shortcut and it gives you the answer.
Sure.
2 times 5 is 10, you drop the 0 in there. That's a big number.
Yeah, it's a big number.
I don't know the answer. It's just move it.
Oh, and it's not an odd. We can't even look to the back, can we?
Or no, if you add a 0, yeah. That's what it is.
You want to look at what pages?
Sure.
Is there pages?
Yeah, I
Okay. I was first bar, second for that last week.
got it's a parentheses 10. Yeah. 10 addition.
Mhm.
And I
So you need 10.
Yeah, this is what you need.
You still get it? I get it. Some you guys don't get it.
I don't know, I don't think we get. So you have to turn in the 10th edition no matter what.
He's better.
I don't know, I mean, I know, so is he trolling or he just really doesn't get it, I can't.
He's messing
He
with
just-
I didn't know you did. I remember looking at Amazon, yeah, $82.
Did you get 44,280,000?
Yep. 1,000.
Yeah. How to say it? Yes. And that would be pins in 6 weeks. Cotter pins in 6 weeks.
Yeah.
They are.
That's a 6-week bar.
That's a lot of cotter pins. It is. Okay. All right. Fun stuff.
Okay.
Bored? Hopefully, right? Just kind of moving along here. All right. Then let's peek at division. All right. So.
Can I start with the final? If we're gonna do longer than.
Oh, let's get through here. So 1-4 is our division section in the 10th edition. This is on page 40. So we see division in a couple different ways, and they show it up here. You can use 12 using the divided by symbol 3. You can use setting it up like this, where you have the, I don't even know what that's really called, just the 3 into 12. You can do 12 over the top of 3 in fraction form, or we can see it a fraction with the slash mark. Okay, so a couple different looks at what division can look like when we see it. So I'm going to peek. We're going to go to page 48 first, and at the bottom of page 48, it shows us those couple different looks there and how to set, and setting up your division. Now, number 10 here. Now I just have to kind of bend my book a little bit. this would be how we would actually enter it into our calculator, right? We would put in 245, hit the division sign, put 7, and then equal 2, right? So go ahead and do that depending on the type of calculator that you have. So it would be 245, using that division symbol, divided by 7 equals, and you should get 35. Now again, if you have a calculator similar to this, that's great. If you don't, I'm certain your phone probably has that capability as well. So don't go out and buy anything special for this class, okay? And we can do the same thing for, you know, especially larger numbers like number 14 down here. 3,310 divided by 3. So it's 1,103.33333, okay? So practice using your calculator, making sure that you know how to do these things, especially when it's the larger ones. I'm not expecting longhand. We'll show some examples of longhand, but truly, your calculator is the more efficient way to get through these, okay? All right, let's do one longhand just because, right? Make sure that we know how to do it. Which one do we want to do?
Which way are you teaching?
What do you mean?
There's multiple ways to learn how to live a longhand.
There are, but we're not going to focus so much on that.
I know you and my mom probably.
Yeah, you and my mom. Yep, that's. I'm in that generation.
It's different than the way they actually talk when I was actually in elementary school.
I know, it drove me crazy.
I know both ways.
Okay, good. Let's do number. I know you're looking at him like I can't believe you just said that to her.
Hey, I'm pretty young.
So why don't we do on page 49? Let's do number 14, and we'll do it the way I learned how to do it, which I think is pretty consistent with most. And you're right, there is more than one way of doing it. But we'll do number 14 here on page 49. And we'll set it up the way they have here, 6, and then goes into 48,009. Okay. So basically we start off, we're going to see if 6 goes into 4. It does not, right? But does it go into 48? It does. So above the 8 then, we're going to put how many times does it go in? It goes in 8 times, right? So I'm going to put the 8 directly above. So then I'm going to take that 8 and I'm going to multiply it by the 6. And I'm going to write below 48 there. Okay, now what's nice is that it actually went in evenly, right? There's no leftover, so this is going to be 0. So then what you do is you look, okay, the 0 comes down. Does 6 go into 0? How many times? 0. So our 0 is going to go above that. Our 0 comes down again, right? 6 goes into, continue into 0, 0 times again. Now I'm going to bring down my 9, okay? 6 goes into 9, how many times? Once, right? So 1 times 6 is 6. And underneath, I'm going to take 9 minus 6 is 3. Now, I've exhausted my numbers here, so what do I add? A decimal place, right? You could say, oh, I've got a remainder 3, but I can keep going with this, right, to get decimals. So if I add a decimal here, I'm going to put a decimal up there. And now this becomes a 0, right? So my 0 comes down. 6 goes into 30 how many times? 5. There it is. And look at, now I'm at no remainders. Okay? It is cool, isn't it? Yeah, there it is. There's that part. So now if I check it, if I go 48,009 divided by 6, I get, look at that, the same answer, 8,001.5. Okay? Yeah, now you guys are impressed. So you did, good. So it's probably the old way of doing it. I don't know. It's, to me, the only way to do it. Okay? Let's do another one, just because. Let's do number, oh, let's not do 18. Doesn't it look ugly? Let's do number, I don't even like 12. Let's do number 16. Let's do number 16.
Oh, we should do one with doubles.
I don't want to do one with doubles. I don't even, those are calculator ones.
All right, that's the way I was calling the other one.
There we go. So let's do this again. Now I like that there's more numbers, that there aren't as many zeros, because otherwise we're pulling too many zeros down. So 3 into 6, how many times? 2, yeah. So we'll go 2 times 3 is 6. No remainder, that's okay. But now we're going to bring down the next number, the 2. 3 into 2, does it go?
0 times.
Nope, we're going to do a 0 above the 2, but now we're going to bring the 1 down. 3 into 21. 7, that goes above the 1. So 7 times 3 is 21, no remainder, that's good. Now we're going to bring the 6 down, right? 3 into 6 goes 2 times, okay? 2 times 6, or I'm sorry, 2 times 3 is 6, no remainder, and now we bring a 0 down. 3 goes into 0 how many times? 0, and there's no remainder here, so we end here. We don't have to do any decimals. So checking our answer, 62,160 divided by 3 equals 20,720. Excellent. Okay. So that's the process that we go through. Should we do a double one? I'm avoiding it,
So in
but
the homework,
should
you're
we?
just okay with the answers for these ones too?
When I'm fine with the answers. I have no problem with that because, again, why not use your calculator? Even if you do it longhand, you're going to want to check it anyway, just to be sure. It's one of those processes. So how many feel comfortable with division, whether it's longhand or on your calculator? Okay. All right. Then let's look at a couple of application problems. Okay. So number 1 here on page 49. Says a machinist has a piece of bar stock 243 inches long. If she must cut 9 equal pieces, what is the length of each piece, not worrying about any cutting waste that you might have? Well, there's a division problem, right? We want to divide the 243-inch long piece of bar stock into 9 equal parts, right? So we're going to take, so this is number 1 in part D. And we're going to take 243. It's going to go underneath. I think it's called a radical. Is that right? I should know that. Underneath, and then we're going to divide that by 9. So the 9 goes out front, right? Okay. So 9 into 20, or into 2, not yet, right? But 9 into 24, how many times does it go? 2, right? So 2 times 9 is 18. Put the 18 down below, and I subtract. So 14 I have to carry, right? 4 minus 8 doesn't work. But 14 minus 8 is 6. And then this becomes a 1, so that's a 0. So 6 is left over. Does 9 go into 6? No. So that means I got it. I did well. I didn't. If you have a larger number on your remainder there, it means, oh, we got to bump that up 1 extra 1, right? But it doesn't, so I'm a good number here. But I'm going to bring my 0 down, right? Did I do that wrong?
Yeah, it should come out to an even number. You're going to come out to it should come out to a whole number. You're not right now.
Oh, it's 243. You're right. I did 240. Yep. Okay, so the 3 needs to come down. So we're going to have a 3 come down. Does 9 go into 63?
Yes.
It does. How many times? 7. Yeah, so we put the 7 above the 3. 7 times 9 is 63, no remainders. So
2 feet and 3 inches.
our length for each one of these is going to be 27 inches long. Is going to be our answer, right? Checking it. So 243 divided by 243 divided by 9 equals 27. Okay. And again, in these practical problems, when there are units like inches in this case, you can either put in the inches in back of it or the little hash marks. You can do inches there as well. Totally fine with it. But do include the units because these do have them associated. Okay? Let's do another one. Ooh, this one's good. Number 8. It says, what is the average horsepower of 6 engines having the following horsepower ratings? So it gives us the numbers, 6 numbers here for the horsepowers. And if you don't remember average is adding them all up and dividing by the number of values that you have. So in this case, we'll add them all up and we'll divide by 6. So we're actually doing a 2-step process here. Okay? So go ahead and add up all 6 numbers. I'm going to do this on my calculator. There's no reason at this point. I know how to use it. I might as well add them all up. So 385 plus 426 plus 278 plus 434 plus 323 plus 392 equals. Now I got 2,238. Anybody else get that?
Yep.
Okay, so I'm going to write that number down. So this is for number 8. So 2,238. And I want to divide that by the number of horsepower ratings that I have, which is 6, to get that average. Okay, so if I'm going to do the longhand, this is what I would do. But I'm not, right? I've got the 2,238 here, and I'm simply going to hit my division sign. Divided by 6 equals. And I'm going to do, and the answer is 373 horsepower, right? Okay, all right.